I, Dr. Kapil Govil, welcome you in this video. In this video, we will discuss about creation of linked list. So, to understand this creation of linked list, we will do it in two sections. First section will be internal structure of linked list in memory. Memory is RAM. So, in RAM, how linked list works. We will understand this concept along with example. And in the second part, we will understand the C program of creation of linked list. So let's start. In the first section, we will understand creation of linked list in memory with example. So first of all, we take example. So let us take an example of internal working of linked list. So here, this structure is top view of bus. Which bus? Roadways bus. Suppose you are traveling from Delhi to Kanpur and you along with your family you have to travel in that bus. So what will happen? This is you. I have denoted it by Y, and suppose your age is 22. This is your brother, stands for B, and your brother's age is 26. Similarly, this is your sister S and age is 24. This is your father, age is 45, and this is your mother, age is 42. All five persons have to travel from Delhi to Kanpur via roadways bus. And this is the road top view of bus, roadways bus. This is driver seat along with the driver gate. This is three-seater seat. This is two-seater seat, three-seater. These are three-seater seats. These are two-seater seats, and this is five-seater seat. And these are numbers, seat numbers. Seat 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 up to 16, 20, 21, 22, 23, 24, 25 up to 41, 42. I hope this structure is now clear to you. Now these circles are some persons, those who are traveling from anywhere to anywhere. But these persons are not belong to your family. Now you have to travel. So I'm correlating this structure into your RAM. Like this is your RAM having some structures. In RAM, some cells are busy. It means some data is available there, and some cells are occupied and some are free, like this. Suppose this is RAM structure and some filled structure are having some data in your RAM and some are occupied. Now you have to you have to fill 5 elements but continuously, like in array. In array, what you do? You store continuous allocation. This is the drawback of array. But here, if condition is this, you cannot store 5 continuous allocation. For example, if you have to allocate this data into this, it will show error message that memory is full. Why full? Because there is no 5 free or vacant seats. Similarly, in this case, seats are available but not anywhere 5 continuous seats are available. So what will happen? In traditional way, it means in array concept, this bus will say it is full, house full is there. But actually, practically, space is there. How many seats we require? Only 5. And how many seats are available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 seats are there, but it will show memory full. Similarly here, how many seats are vacant? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 seats are available, but this bus will show, if we are using only static array, then it will show error message that bus is full, house full is there. So here linked list or data structure comes into the picture. This is just one example. Not only the only concept of data structure, there are so many concepts, so many examples are there, but I am taking just one example to explain you a linked list in better way. So condition is you have to travel from Delhi to Kanpur via this bus and you have to sit there. What you will do? You have to sit anywhere where you find seat For example, this is you, Y. What is the seat number? 5. Seat number is 5. Your brother will sit. For example, this B, seat number is 35. Your sister is sitting here. Seat number is 29. Your father is sitting here. Father is sitting here. Seat number is 9. And mother is sitting here. Seat number is 26. This is the condition. So I am talking about your family only. So I am marking this. Let's see if this person, you don't know this person, if this person is asking you that who is this? This person is asking you that who is this? What you will say? I don't know. This person is asking you that who is this? What you will say? I don't know. No. You will say, this is my brother, this is my sister. It means no matter how far are you with your family members, you have some link. It means you know where your brother is sitting right now, where your sister is sitting right now. Brother knows where the sister is. Sister knows where the father is. Father knows where the mother is. It means no matter how data is far, but if we have to create a link, then we can have the address or link. So here I am taking just one example that you know the address of your brother. Brother knows the address of sister. Sister knows the address of father, and father knows the address of mother. Address means seat number. So if I am stretching you and your mother like this, if I am keeping in one hand and another hand this and stretching this by putting like this. These are 5 persons: you, your brother, your sister, father and mother. What is the seat number? Seat number is, I have already mentioned, 35, 29, 9 and 26, and these are age. Age you know. It's not mandatory that you have to store age. You can keep mobile number or address or any Aadhaar number, PAN card number, whatever information you want to store. And for simplicity, I am keeping age so that you can understand easily. So it means this structure is linked list. These are some members, nodes, and each one is linked to each other. The technical representation of this list I am showing in the next image. Now this is the technical structure of linked list for this logic. So here this person, you, having age 22, seat number is 5, and you know that where your brother is sitting at seat number 35. Similarly, brother is having age of 26 and sitting at seat number 35 and knows where the sister is. Seat number is 29. Similarly, your sister age is 24, sitting at 29, and she knows where the father is sitting at seat number 5. This is the concept. So this concept is called as linked list. And you can notice that at mother is not having any address of any other person because only 5 persons are there. Total 5 persons are covered. So there is no need to store any data for any other person. She doesn't care any about other persons. Right? You may think that why we are not knowing, why you are not knowing about sister's location, and why you are not knowing about father's seat number. So you may think about it, but answer is yes, of course you can store address of each member, but it will be like this structure. Suppose this is you. So you are storing 4 persons address. So this will be age, your age 22, seat number 5. Your brother will be at 35. Sister will be at 29. Father will be at 9 and mother will be at 26. But you may be getting confused by seeing so many numbers. So that's why I have not mentioned any other number for the simplicity of the program and concept. In majority of books, you will find only one number, one address. Later on in videos, we will understand how to tackle with more numbers or more address location. You need not to bother about it right now. So this is the structure of linked list technically. Now we have to create a program so that dynamic allocation, this is dynamic allocation, can be done through C programming. So what is dynamic allocation and static allocation? In dynamic allocation, you can place any data anywhere and you can fetch any data anytime. But in static allocation, that is, you cannot store static dynamic allocation. Means you need, if 5 persons are has to be placed, then you need 5 continuous allocation. But in this case, you can fill 10 more elements because 15 seats are there vacant. So this is dynamic allocation. That's why you need data structure concept. In data structure concept, now you are learning linked list concept through dynamic programming. So let's see how to deal with dynamic programming in C language. So here we will see one program of linked list. So this is C program that we have to understand for the same example. That example I have noted here. That was your, this is you, your brother, sister, father and mother, along with your age and seat numbers. For suppose this reason, we have to design a program. So this program will be for any example for linked list. It may be this example or any other example, any other age or any other seat number. So this seat number is actually of bus number. But in RAM, this address will not be like that. It will be like 12086 or 48492, like this. Why this type of number? Because before this number or seat number, memory is busy or filled. Before this number, memory will be busy, or after this number, memory may be busy. So this is random number that will be provided to you through RAM. Actual working at RAM, you are working here. So this type of number will not be shown when you design this code in your system. This type of number will be displayed to you. So let's see. So first of all, we should understand what this type of code I have written here. So this is first part. I have mentioned the second part here. Means this part has to be written here, and then again board is short, so I have mentioned this structure here. So this structure, this code have to be written here. I hope it is clear to you. I have named it as A, B and C. Okay, so after A you have to write B, and after B you have to write C. And this was our example. So what I have written here, first of all I should read it so that you can understand what I have written. Then I will explain each and everything. So this is hash include stdio.h, hash include malloc.h, integer counter equal to 0, counter equal and I equal to 1, struct link, integer number, struct link pointer next, void main, struct link pointer head equal to null, struct link pointer start equal to null, struct link pointer new equal to null, char r equal to capital Y, CLR SCR while r equal to capital Y, then new equal to struct link pointer malloc size of struct link, printf node number slash n node number %d I, printf enter any value, scanf %d ampersand new arrow number. You can type this arrow like hyphen, that is minus sign and greater than sign. and flush stdin. After that, if head equal to null, head equal to head equal to new, head start equal to new counter plus plus, else start next arrow next equal to new, start equal to new counter plus plus. Printf, do you want more node? Flush stdin scanf %d r equal to 2 upper r. Then start equal to head, for loop I equal to 1, I less than equal to ctr I plus plus. Printf /n/t, value at node number %d is %d and address is %u. I start arrow number ampersand start arrow number, start equal to start arrow next, flush stdin get ch. Now I will explain everything. So because you have done, I am sure that you have understood C language, so you have used stdio.h header file, standard input output. Next you have to create some memory. For that reason you have to use some files that are used for memory allocation. So for this reason you have to use malloc.h header file. Then we have used some variables, ctr means counter and I. Initially I have mentioned that 0, counter is 0. Counter is 0 means there is no node is there. This is your memory, for example. This is your memory and no node is there. So counter is 0. How many nodes are there? 0. No node is there. And I is 1 means for counting something. We will count something. Now I have created one structure with the name link. You can create any structure with any name, but because I am writing program of linked list, so that I have created with name link. Then integer number and struct link pointer next. This pointer is adjacent to next. Why I have written this two section? Because I have to create a node with two parts. First part will keep number, this will keep number, any number, and second part, because you can see pointer, this second part will keep the address of which? Of link type of structure. It will store address of same type of structure. This will store same type of structure, address of same type of structure. So pointer represent that it will store address of which? Struct link. Okay, I hope this is clear to you. Now main function is started here. Then we have used three variables, head, start and new. Which type? Node type, struct type with the name link. This pointer is adjacent to head, pointer is adjacent to start, pointer is adjacent to new. So three names are there, but actually these are not existing. Some three names are reserved in memory, but they do not exist in RAM right now. Next, one character R. You may take any other variable name, is having value capital Y. Capital Y stand for yes, we are interested, or yes, we have to insert a node, like this. Clear screen is it means your screen is clear. You can see while R equal to Y. While R is equal to Y. It means if value of R is capital Y, is it? Yes, we have already stored. It means we have to execute this while section. This is starting of while and this is ending of while loop. So what will happen? This will happen. This and this will happen. So here new equal to struct link pointer malloc size of struct link. This line should be considered and read through right hand side. So here structure link size of. So first of all we have to find out size of a structure link. We have to find out how much size will be occupied, how much size will be required to store that data. So this function will calculate the size of structure link. Then whatever size has been reserved or calculated, it should be memory allocated. There should be memory allocation scheme for size counted, already counted. Then that memory allocation should be reserved to structure link, because we have to link to structure, we have to redirect to structure, we have to allocate to that structure by this statement, struct link pointer. So this will be using that memory, and that memory is named as new. So it means in RAM there will be one structure with two sections. It should be having some address like this 1200, and name of this structure will be new. Then we will print node number %i. There will be one message on your screen that node number is I. I means 1. Node number is 1. Node number 1 message will be there. Then enter any value. This message will be displayed. Then scanf ampersand new arrow number. It has two sections. This will be store number, and this will be next address. How? Here we have written that number. So this new node of structure link will having two sections. First section will be number, and second section will be pointer next. Pointer next means address of, for storing address of any other structure. So new arrow number, in this suppose we are storing age 22. You can store any data, any integer number. I am taking the same example so that you can understand clearly. So you are storing 22. Now flush stdin, because now you are executing this program through dynamic mode. Dynamic mode means you are interacting directly with RAM. So there's maybe some garbage value. So avoiding this garbage value, you are using flush. You are flushing out all the garbage and taking standard input. Now if head is null, where is head? Head is nowhere. It means head is null. Yes. So head should be new. Where is new? This is new. So head should be new. So it means this node has two names, new and head. And start equal to new. It means now this node should be named as start. So this single node has three names, new, head, start. Then counter plus plus. What is the value of counter? Counter is 0. So what is the value of counter this time? Counter is now 1. How many nodes are there? 1. So counter is 1. If head was null, then we have executed this. It means that if we are here, we should not execute this. We should go here or here. So when we are here, so it means after executing this, we should come here. So one message will be printed like, do you want more node? Because again, you are dealing with the character and string values in memory. Again, garbage value may be generated. So avoiding this, you are using flush stdin. So because we are taking character value, so here we are using this flush. So now we have stored in R. Whatever R is having, this is R variable. Suppose user has entered small y for giving yes, I need to enter more node. So whatever is given, it will be converted into two uppercase, and it will be converted into and stored into the same variable. So it will be capital Y. While is ended here, so it means it will check again. While R equal to yes, R is yes. So it will create again new node. New node will be there, and address maybe like 1202, and name will be new. Because this is the RAM, in RAM or memory space, there should may not be two nodes with same name like new and new. So new node will be named as new. It will be not be new. Now at this time this node will be as head and start, but this one is new. What will happen now? Node number 2 count, because counter is I is now 2 now. We have not incremented I. So you can increment here. I should be incremented. Then enter any value at new number. So new number is this, number part is this, and next part is this. So in new number you can store 26. Then you are memory refreshing. If head is null, is head null? No, we can see head is there. So it means we should come here. So what to do? Start next equal to new. What should we change? This one should be changed. This one should be updated. So start next. Where is start next? Start next is this. Start is this and next part is this. Should be new. So it means it will store address of new. Why it will store address of new? Because next is pointer variable. So it will store only address. So what is the address of this? 1202. It means it is linked now. Next, start is now new. Where is new? New is that. So start will now this. Counter plus plus. Counter is 2 now. How many nodes are there? 2 nodes are there. So counter is 2. Then do you want more node? Again, memory refresh, store Y, capital Y and Y. Again, new node creation will be there. Because this is a new node, so this name will not be new. Now enter any value, new number, for example 24. Memory refresh. If head null, no, head is not null, head is there. So else part, start next equal to new. Where is the start next? Start is this, next part is this. We'll store the address of new. Address of new is 1204. It means it is now linked. Start equal to new. It means start should be at new. Counter plus plus. Counter is now 3. Similarly, for 4th iteration and 5th iteration, it will be, this is for 4th iteration. And counter here will be 4. And at the next iteration, it will be this iteration, and counter will be 5. So after this, what we have to do? We have to print this linked list, but whatever we have stored, we should print it. So start equal to head. Start should be here. So till here we have created linked list. Now we are printing. Just this these statements are for just printing. So start equal to head. Start is now here. Now for loop, for I equal to 1 to counter. How many nodes are there? 5. So 5 times it should be executed. What we have written? Printf. Value at node number %d. First %d means first value. That is I. I means 1. So value at node number 1 is %d. Again, it means second. Start number. What is the value of start? Start number 22. So value at node number 1 is 22 and address is. These statements will be printed when you actually execute this program on computer. Okay, I am not writing the actual statement. So it will be printed like value at node number 1 is 22 and address is address of start number. start number, address. What is the address of start number? Is 1200 and address is 1200. Start equal to start next. Start will move to next. Start next part this. So what is the address? 1202. Where is 1202? Here. So start will be here. Memory refresh. So again I is incremented. Value at node number 2 is 26 and address is 1202. Again start will move to the next here and it will print 3 and 24 and address is 1204. Similarly for next iteration 45 and address is 1206, then 5 42 node and 1208. So this is the complete code for linked list in C language. I hope you can understand. Still, if you have any doubt or any query, you can write in comment section. I will try my level best to answer your query. So there is one small request to you. If you are watching this video on YouTube channel, then please subscribe this channel. And if you are watching this video on Facebook page, then please follow this page. So thanks for watching this video.